Let's see the difference between voltage and current. Voltage is the force that makes electrons flow. It's a difference in potential energy between two different points in a circuit, whereas current is the rate of flow of electrons. Sounds difficult to remember, right? Don't worry. With upcoming live examples, it becomes familiar to remember. Here comes our live examples. Let's imagine that we have the water tower which is connected to the pipeline with pump to the borewell, drawing the water to the tank. When the pump is on, the water is drawn from the borewell and the tank is get filled. After filling the water, right now the water tower have lots of potential energy to do work, but isn't it releasing the energy from the water tower? Let's connect another pipe to the tank and open up the water to flow the water out. The water flowing from the pipe is mean to the current. With this example, the flow of water is mean to be the current in the circuit. The potential energy stored in the tower is known as voltage. When you try to increase the size of the flow pipe, the voltage remains same whereas the current increases. When you remove the flow pipe, there is no long we have current, but the voltage in the tower remains same. Still we have the potential energy. Still the tower has the potential to do work. In the same way, the batteries have voltage associated with it. Even if it is not connected to the circuit now, still has the potential energy or voltage remains the same in the battery. The original definition of voltage. Voltage is the force that makes electrons flow. It is a difference in potential energy between different points in a circuit. With this definition, when you see the example where the gravity is the force applied here from point A to point B to pull the water down, is meant to be the two different points in a circuit. The voltage in the water tower would rise when you increase the difference between two points A, B. Voltage always represents the potential difference between two points. When referring to our 9-volt battery, the potential difference between the two terminals is 9 volt. In example, whereas the gravity is applied force, and here with electricity it is electromagnetic force. Electromagnetic force is where the interaction between electrically charged particles. The electromagnetic force causes electrically charged particles to either attract or repel each other. If you use an electrically conductive wire to the connected circuit to the battery, the electrons from negatively charged side of the battery are drawn to the positively charged side by a force corresponding to 9 volts. Without voltage, electrons move randomly in all directions, but voltage directs and pushes the electrons through the circuit. I hope the definitions make sense now. Voltage is the electrical potential difference between two points in a circuit which drives the flow of electrons, and the current is the rate of flow of electrons in the circuit. Hope you understand the difference. We'll compare resistor and trans resistor in next video. Please subscribe our channel. Stay tuned with Subrokers.